Okay, so we would be looking at a parabola, right? A y equals 4 minus x squared. That's a x squared, which is a parabola. The negative does what to your parabola? Yeah, flips it upside down, and the plus 4 moves it up 4, okay? Also might look at it as y equals negative x squared plus 4. That's just how we're more used to seeing it in standard form. ROX up 4. So there's my vertex. I do want to consider where it's going to have zeros, and that would have zeros if I were to set that equal to 0 and solve. It would have zeros at 2 and negative 2, right? So it's going to go through my x-axis here at negative 2 and positive 2. It would look something like that. They are asking us on this first one to consider the area between the x-axis. So one of the sides of my area shape has to be the x-axis, and that's where a lot of us kind of lost it on our integration part when we first were introduced to integration. From 0 to 2, which means I would be using this as one of the sides of my area and then connecting that to my graph, which would end up being this little shape right here. That's the area we are finding on this particular one, and because that is all above our x-axis, as we look from 0 to 2, we can use one integral, just a positive normal integral from 0 to 2 of our function, 4 minus x squared. We will always include our variable of integration as we write our integrals. And today, for just to speed things up, we're going to grab our calculators and do Math 9. That's definitely one we could do in our head, right? I could find the antiderivative of 4 minus x squared. It would be, what, 4x minus 1/3 x cubed, and evaluate from 0 to 2, but we don't need to practice that at the moment. And who's got that typed in for me? Okay. Looking at that exact same function a couple times here just to talk about, okay, well, what happens as we change the interval in which we're looking at that, and how does that change how we set up our integral? So initially, we're looking at the area, and so, yeah, in my head it says, okay, we'll go from negative 3 to 2 then, right? Okay, but if we were to consider the graph itself, again, in that area, we know that our graph's going to hit at negative 2 and at positive 2, but at negative 3, if I were to evaluate that function at negative 3, come up to my function and plug in a negative 3, negative 3 squared is 9, 4 minus 9 is negative 5. So we would be looking at a graph that looks something like this. And we're supposed to be evaluating from negative 3 to 2. And do you see how it flips now? We've got some of that below our x-axis and some of that above our x-axis. This part of your graph is below my x-axis, which means that would be a separate integral. Here's my x-axis, here's my curve. That would be the area we are finding below our x-axis. From negative 2 to positive 2, here's my x-axis, here's my curve. The area that we'd be finding in there is above our x-axis, so we would need two integrals on this one to account for the part that's below and the part that is above. So this would not have found the correct total area. That would have taken our positive minus the stuff below. We need to break it up. That first integral that is below on the x-axis goes from negative 3 to 2. Negative 2, sorry. And because we know this is going to give us a negative value and we want total area, you either need to put a negative in front of that integral, or as I always do, put it in absolute values. And then add to it the positive area, which would go from negative 2 to 2. And again, that's a grab my calculator and type that in type of thing. We are not going to spend any time doing these in our head. As soon as somebody's got that typed in, I'll take it from you. questions on that? All right, then the last one, I think you can draw by yourself, so go ahead and try that one on your own, see how you would set up your integrals. So first things first, again, drawing ourselves a picture, and this time from -5 to 5. Kind of hitting some of the highlights on there. If I were to evaluate our function for -5 squared is 25, for -25 is -21. So at -5, we'd be down at -21. Same thing at +5, we'd be down at -21. We know it's going to go through our x-axis at 2 and hit up at 4. Okay. And then remember that as we switch from being above to below, you have to switch your area because the x-axis is going to bound one of the sides of our area. So we've got this section here that would all be below. That would be our first integral using the x-axis as our bound and our graph as the other. That would be our first integral all below our x-axis. So we would take its absolute value from -5 up to -2. Our second one will go from -2 to 2. That is all above. Again, using our x-axis, and the function gives us the area above our x-axis. We don't need absolute values. It would not hurt our answer if we did. And our last one is going to start at 2 and go to 5. Again, connecting our x-axis and our function for this area below. So 2 sections that were below our x-axis, and what are we getting for a total on that? 64 2/3. Any questions on this? All familiar? Yes, we've done this before. Okay, just bringing this back into our brains as we start going into section 8.2, which is all going to start with the concept of area between a curve and x-axis, y-axis, something, but the area there. You guys have